we'll do series. So we did see that if we say a plus b to the power n, which is n0, an plus n1, an minus 1b plus n2, an minus 2b2 plus nr, the general term, an minus rbr plus nn bn. So this is the binomial theorem. Then we resolved this to be ab power n. If you solve this, we are getting an plus an minus 1b plus n minus 1 over 2 an minus 2 b2 plus n minus 1 n minus 2 over 3 factorial n minus 3 b3. We can keep going. And if we have a case of this nature, if we put a 1 here, and then we have n, the expansion becomes very easy. You get a bx plus n minus 1 over 2, the bx squared plus n minus 1 n minus 2 over 3 factorial bx to the power 3. And it keeps going like that. So now I want to appreciate the third line in the application. Okay, so we'll go straight into examples now, where we say find the binomial series expansion of the following up to and including the term in x to the power 3. So we'll move up to the term in x to the power 3. So we'll start with a very simple one. 1 plus x to the power -1. So in this case, I will see that from these expansions here, well, our n is -1. We have 1, then the whole bx is just x in this case. So in expanding, you say 1 plus n is -1 multiplied by bx, which is just x in our case, plus n, which is -1, and then n minus 1 over 2, and then x squared, and then plus -1, -1 minus 1, -1 minus 2 over 3 by 2, and then x to the power 3. And then it goes like that. Then we simplify. So we have 1 minus x. Then -1 minus 1 is -2. So this 2 and this 2 can cancel. Then we have negative times negative. It becomes positive, and so we get x squared like that. Then this is -2, this is -3. So this 3 and this 3, this 2 and that 2. Then the negative will remain. x to the power 3. We could keep going, but the question says up to and including the term in x3. So this is the expansion. And we call it a series because it keeps going. We've just been stopped at x to the power 3. If we extend the question, state the range of values of x for which the expansion is valid. It means we will now say the expansion is valid for the absolute value of x. This absolute value of x is less than 1. We should have answered the issue of validity like that. So what is key is knowing this here. The last one is well simplified and is easy to use as compared to the first two. So if you can force a 1 on the first one, then where there is, okay, this one I've already explained it here, like where there is A, you're putting 1, 1, you just pay attention where there is BX. So in this case, we still have 1, where there is BX, we just have X. So we're substituting where there is, wherever we are seeing N in this line here, you substitute -1 all the way up to x to the power 3. That's how easy it is. Then for the range of validity, you just get the B part in the modulus less than the A part. And these are not complicated. To expand the series is the very easiest thing to do. Another example, B, the root of 1 minus x. The root of 1 minus x. The validity part, okay, don't worry, I'll get back to the validity part. Okay, so if you are told to expand the root of 1 minus x, what's the power here? Okay, so you realize that the power is positive half. So this power is our n. So we're saying in this case, n is equal to half. Okay, and the whole bx in the formula is just -x in this formula here. So we're substituting now on the right. So say, okay, this is 1 plus n, you put half, multiplied by the bx, which is -x, plus n, you put half, n minus 1, that is half minus 1. Okay, over 2, and then -x squared. And then plus half minus 1, and half minus 2, over 3 factorial is 3 times 2, and then -x to the power 3. Like that. Then you come back and simplify. What is half minus 1? Half minus 1 over 1. Common denominator 2. 2 into itself 1 minus 2. So you get -1 over 2. Okay, what is half minus 2 over 1? 2 common denominator, 1 minus 4. So this is negative 3 over 2. So here we have minus 3 over 2. Here we have minus half. Here we have minus half. Okay. What else do we need to calculate? We have half over 2. What is half over 2? Half over 2, half over 2. This is like half over 2 over 1, which you can write as half divided by 2 over 1, which you can say half multiplied by 1 over 2. So this is telling us that, oh, then we're going to be multiplying the denominators. So you say, from here we have 1, and then minus 1 over 2x. And then this 2 times this 2, we get 4, times this 2, 8. So we have plus 1 over 8. And then negative x squared is just x squared. And then this 2 times this 2, we get 4 times 2, we get 8 times 2, we get 16, because this 3 and the top 3 there will cancel. So we have 1 over 16, and then negative, this negative times this negative, we get plus. Then negative x to the power 3, we still have a minus, and then x power 3. So that's how you get this expansion. Okay. How do you find the range of validity here? The range of validity, well, we don't care about what the power is. We're interested in the inside here. So we pick the B part, range. We pick the B part, negative x, put it in the modulus less than the A part, so that we get the modulus of this guy less than 1. So though the two expansions are different, they have the same range of validity. Like that. Okay, so now we do another one. C. Okay, what happens if this is negative? And then we have maybe 3x here. And then to the power, maybe negative half this time around. But let me put it this way. 1 over the square root of minus 2 plus 3x. expand this. So here you say, okay, first thing I will write it as 1 over -2 plus 3x to the power half. Then the next thing, it will be -2 plus 3x to the power -half. Like that. Like that. Then, because we have a 2 and we have a 3 there, we want to have a 1, so that is easy to expand. So we write this by factoring out a 2, so that we remain with 1 minus 3 over 2x together to the power -half. Okay. But we know that we can always factor out the -2. So we have -2 to the power -half. And then we remain with 1 minus 3 over 2x to the power -half. Then now we can't expand this. This one will just keep waiting. So pay attention to this one here in our expansion. So say we have -2 to the power -half. And then we now expand this. We have 1 plus -half multiplied by -3 over 2x plus -half, -half minus 1 over 2 multiplied by -3 over 2x squared plus -half, -half minus 1 and -half minus 2 over 3 by 2 and then -3 over 2x to the power 3, which we simplify now as -2 to the power -half. And then we have 1 plus 3 over 4x. I've multiplied here. Remember, this is -3 over 2 now. So we'll have negative, giving us plus, and then 3 over 2 times 2 times 2, we get 8. And then -3 squared, we have 9 over 4 x squared, and then -3 over 2 minus 5 over 2. So this 3 and that 3 is to cancel. Negative, 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 negative. So it will be plus, and then 5 over 2 times 2 times 2 times 2, we get 16. And then -3, 3 to the power 3, that's 27 over 8, then x to the power 3, like that. Giving us -2 to the power -half. And then you just put these together. So you have 1 plus 3 over 4x plus 27 over 8 by 4. That's 32 x squared, and then plus 5 times 27, 5 by 27, we get 135 over 16 by 8, we get 128, and then x power 3 plus, so this will be our expansion. So don't get bothered about this negative in the root. It's okay, we'll just leave it there. Like that. What about the range of validity? Range of validity. So the range of validity, you pick the inner one. So this, so we'll pick absolute value of 3 over 2x to be less than 1. Okay, so this will come out as 3 over 2. You know what the absolute value does to the negative. And then you multiply this side by 2 over 3 and this side by 2 over 3 so that we get the absolute value of x to be less than 2 over 3. Like that. So it should make sense that way. So now, it should be easy for you to get this series. Then now they say, use binomial series expansion to find the approximate value of the following. Okay. A, find the value of 1.01 to the power -2. When you are given this question, do not use a calculator. That is not binomial series. Do not take it as 1 over 1.01 to the power 2 and start calculating. That is not binomial. When we say binomial series expansion, then look for a binomial series. Find it and use it. Okay, so you can pick the simplest binomial. There are so many series that you can use here, but you can go for the easiest one, where you say, okay, every time I see such a question, I will be expanding 1 plus x. Where do you get the power? You get the power from the given question. This question has the power -2. So you use -2. So you have 1 plus -2 is our n. So remember, -2 multiplied by x plus -2, -2 minus 1 over 2 multiplied by x squared plus -2 -2 minus 1, -2 minus 2 over 3 factorial, so 3 by 2, and then x power 3. You end at x3, it's always okay because it gives us the good approximation. Then you simplify. This is 1 minus 2x. This 2 and this 2 will go, and remain it plus 3x squared. This 2 and this 2 will go, this 3 and this 3 will go. So you remain with minus 4x to the power 3. We have found the expansion, the binomial series that we can use to find the value of 1.01. Okay, because we are saying this is 1 plus x to the power -2.
It's supposed to be plus 3x or -2.
Plus, because we have negative terminal.
Oh, we should use negative means in the cancel.
Yes. Then now you get the inside. You get 1 plus x and equate it to 1.01. 1.01. What we get? We get x is equal to 1.01 minus 1, giving us 0.01. What we are trying to do here is we want to see which value of x can make the inside here be equal to the inside of the actual question. That is 1.01 to the power -2. We have used power -2, but we need to equate the inside also. Remember, if the powers are equal, the bases must be equal. So we get to the base and make them equal. So I'm looking for the value of x that will make those equal. And the value of x here is 0.01. Why? Because we know 1 plus 0.01 will give us 1.01. Okay, so now we know if we say 1 plus 0.01 to the power -2, we will be saying 1.01. To the power -2, do we have to expand again? No, we already have the expansion here. The beauty is we've just known the value of x. So we'll now take the value of x. 1 minus 2 multiplied by 0.01 plus 3 multiplied by 0.01 squared minus 4 multiplied by 0.01 to the power 3. Like that. And then well, on the left, this is just 1.01 now. We know it's equal to 1 minus, you multiply here, you get 0.02 plus 3. This is 0. How do you multiply that? A calculator? You just count. We have 2 decimal places to the power 2. So you count 2 times that 2. We now have 4 decimal places. And because of the 0, 1, you have 3 zeros and 1 of the last number. Minus 4, we have 2 decimal places multiplied by 3, there should be 6. So 1, 2, 3, 4, 5, and then 1 makes it 6. Then you expand again. So I have 1 minus 0.02 plus 0.1233 minus 0.12345, like that. Then we have 2 things to do in subtracting and addition. So let's just add 1 plus 0.003. It will be 1.0003. And then we also add this 0.02 minus this one. They're all negative, so we'll have minus 0.02004. 1, 2, 3, 4, 5. And there should be 6. So there's another 0 here. 0, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, there should be 6. Then now you subtract. So you say 1.00030 minus 0.02004. This is like you get a 1 from here, remain with 2. This will be 9, that will be 10. So you get 6, 9, 2, 0. Then there's a 2 here, so we get a 1 from here, remains 0, 9, 10. 10 minus 2, 8. 9 minus 0, 9, and here 0. So now we get approximate value. This is 0 0.980296. If you punch the calculator, we'll punch it as 1 divided by 1.01 to the power 2. You get 0.980296,049. So because we are approximating up to the 3rd degree there, that's why we are accurate up to 1, 2, 3, 4, 5, 6, 7 numbers. So this binomial can help us get the actual value without using the calculator. As you can see here, and it can approximate anything. Exercise for today. On the Torah sheet and answer that whole question on series. Okay. You move a step, answer the next question that is on the application of series. But if they said, so for this one, they can't say find this validity because they are dealing with an actual number here. So if you find something like root 17, then you take your time, you write it as 1 as 16 plus 1, you put it like this to the power half, and then you don't use this as A, that as B. You put the 16 out and remain with 1 plus 1 over 16 to the power half. This is what you're going to do as the expansion. So where you place X here, do the expansion, then substitute 1 over 16 wherever there is X. But don't worry, just try. I will talk about it more tomorrow. But today that's where I will end. We're supposed to go for more sessions, but unfortunately we won't. Tomorrow we'll have our class. And remember, we're just remaining with partial. This is getting done slowly. And partial is just one session, just like 40 minutes. But because we're taking our time, we can do even 80 minutes on partial. It's not a big deal. And then start revising everything. Preparation for the quiz. So we link up tomorrow.